good morning, everyone. So now we're going to continue. Good morning, everyone. So now we're going to continue Unit 9, except we're not just going to look at answers as they fall on a number line. We're going to look at answers and solutions on a plane. So like how we started at the beginning of this year when we had graphs, and we looked at what does it mean to be a solution to a linear equation, and also in 2 dimensions, and also a solution now to a linear inequality. All right, so let's go ahead and start that. So what if the linear inequality has 2 variables? So in the very beginning, we looked at solutions that we solved problems like this: 2x plus 1 less than or equal to 6, right? And if we were to solve it, we would have ended up with something that was on a number line. We would have had 5 halves here. It would have been a closed dot. We would have done all the work to realize that's what it looked like. And then our solution would have been written something like that. We also had cases where the answer was the entire number line, right? That's where all our variables disappeared, and we ended up with some sort of a true statement, like 4 is less than 10, right? So that's all real numbers. And then the final case that we considered was what happens if we had ended up with a false statement, like 4 is greater than 8. That's false, so that's nothing, so we'd write no solution, right? And this was all real numbers. And then we looked at absolute value as well. But let's go ahead and go back to this idea of inequalities, but we're going to look at it with 2 variables. All right. So let's start with this. What I'd like you to do, okay, there is no poster. Obviously, this is meant for a classroom. But what I'd like you to do is go ahead and graph that. All right. So let's see. Just as a quick reminder on how to graph. This is the y-intercept, so I know I'm going to start at 3. I'm going to go down 2 over 1, down 2 over 1, and then I'm just going to get a ruler or something. Just going to draw one more dot. And there we go. So there's my graph. All right. So the first question is negative 1 comma 5 a solution? Well, I can look at the graph, and if I would have just went, right, I could go back 1 up 2. The point is on the line, so it is a solution, right? So looking at the graph, the point, negative 1 comma 5, is on the line. Therefore, it's a solution. Right? That symbol means therefore. All right, I could also check it by using the equation, right? And that was the whole point of us testing points. If I plug in x and y into this equation, and it's true, then it's a solution. So let's go ahead and check it. 5 equals negative 2 times negative 1 plus 3. So this is a question. I don't know if it's true or not. So we've got 5 equals 2 plus 3. Therefore, 5 equals 5, which is true. Since it's true, it's a solution. All right, what I'd like you to do is go ahead and try that. Is 2, negative 1 a solution, and is 0, 0 a solution? Be able to verify it both with the graph as well as algebra. All right, so let's verify both of these graphically first. Is 0, 0 a solution? No, because it's not on the line. Is 2, negative 1 a solution? Yes, because it's on the line, right? So that's all it is. So now let's do it algebraically. Let's test 0, 0. So we're going to plug 0 into the equation. This is false, so it's not a solution. Let's go ahead and test 2, negative 1. Right, this is x and y, so I got to get the order correct. I'm going to substitute x and y into my equation. So we get -1 equals -1. That's true. So this is a solution. And this is not a solution. Oops, I lost the page. Sorry about that. All right. Again, 0, 0 is not on the line. 2, -1 is on the line, and it's consistent with my algebra. All right. So the question is, what determines if a point lies on the line? What's the difference between points on the line and points not on the line? So if the points fall on the line, that makes the equation true. Therefore, it's a solution. If points are not on the line, they're not going to make this equation true. Therefore, it's not a solution. And this is kind of a review of what we already know, but we're going to use the same example and bring it to the next level. All right? So now I'm going to change the problem a little bit on you. What if I wrote the problem like this? Same numbers, except I'm going to make this a greater than or equal to. What would my final answer look like? Well, let's take a look at determining where all my solutions are. So I'm going to start with a piece of graph paper just because it's going to be a little bit easier to work with. And pull the camera up. There we go. All right, I'm going to go ahead and graph this. And if you'd like to pause the video and graph it on your own, it's going to be helpful. You're going to want this graph. All right. So just like we've done in the past with taking a point and testing it, I'm going to do the same thing. So we'll do one together, and then I'm going to have you guys do a few on your own, and then we'll take a look at what conclusions we can make. So let's take the point 2, 2. So I'm going to test this point right here. The way I test it is I plug it into my inequality, and I determine if it's true or false. All right, so I'm going to do that right over here. I'm going to take the point 2, 2, and I'm going to test that point. All right, so I'm going to plug in. This is x, this is y. So is 2 greater than or equal to, and both of x and y are 2. So -4 plus 3. Is 2 greater than -1? That's true. So I'm going to put a little t here for true. All right. What I'd like you to do is test the following points. I'd like you to test 0, 0, 3, 0, 2, -1, 2, 3, and -1, -1. All right, and I'm going to leave, I left a little bit of space so I could do them all right there. All right, let's check your answers. So again, I'm going to plug in these points into my inequality. So the question is 0 greater than 3? That's false. So the point 0, 0 is false. We test the point 3, 0. So don't forget, that's x and that's y. So I got to put them in the right spots. So is 0 greater than, this is -6 plus 3. Is 0 greater than -3? That is true. So the point 1, 2, 3, 0 is true. All right, let's test this point. It might be helpful to put a little x and y just so that you don't forget which is which. So is -1 greater than or equal to -1? That looks weird, but -1 is equal to -1. That's true because of this bar right here. So this is going to be true. So on the line itself, to -1, this is true. All right, let's test 2, 3. Is 3 greater than or equal to 1? That is true. So 1, 2, 1, 2, 3. And then the last one. Is -1 greater than or equal to 5? No, that's false. So the point -1, -1 is also false. So what I'd like you to do is take a look at this. Do you notice anything interesting? All right, what if I were to pick this point? What do you think that would be? Yeah, that would be false. What do you think that point would be? Yeah, that's true. What do you think that would be? False. The reason why, this line kind of serves as a boundary point or a dividing line. What do you notice about everything on that side and everything on this side? Yeah, so this side would get a big, this side up here would get a big true. If something's true, that's the side we shade. And notice what I do, how I like to shade it is from my line, I like to go perpendicular to it. That way it's clear that I'm shading everything that's over there, all right? Make sure your line is drawn long enough so it's clearly that half of it gets shaded, all right? Why don't you try one more? I'm gonna make one up for you and you guys can try it, all right? All right, so the very first thing that we're gonna do is go ahead and plot them. Well, let's go ahead and graph this. So we're gonna plot the y-intercept, 1, 2, 3, -3, up 2 over 1, up 2 over 1. We'll go one more up just so that I get a better line. Now I've got to test a point. So the first thing I do is draw the line. The second thing I'm going to do is test a point. So I'm going to test, I like to test out of all of these, which one would seem to be the least amount of work? It was this one, when I tested 0, 0. Everything took 3 steps, except for this one took only 2. So that's the point I'm going to choose. You can choose any point you want. But I'm going to choose 0, 0 because it's less work. So now I'm going to ask myself, is 0 less than or equal to 2 times 0 minus 3? In other words, is 0 less than -3? No, it's not. So this is false. So I'm going to put an F here. So if this side, remember this is my dividing line, if this side is false, what does that mean about this side down there? Yeah, the opposite side is going to be true. So this is the side that gets shaded. All right, if that's false, the true side gets shaded. And then I just shade everything. Remember, this goes on forever and ever. So that's sufficient to show that. All right. All right, in tonight's homework, I think you have a couple to try, so I'm going to let you go ahead and try those. And if you have any questions, please let your teacher know.